In the previous class, we have discussed one problem on polar plot. Let us solve some more problem to get easy exposure regarding the polar plot. I will recall the basic procedure of polar plot. First, what we have doing in the problem is, first we will be considering the open loop transfer function. Open loop transfer function is g of s, h of s. This is also called as frequency response function. So this is the first step in the problem, whether they have given open loop transfer function or not. That is what we will be tracking. Otherwise, get the open loop transfer function g of s, h of s. Then after that, replace s with j omega, so that g of j omega, h of j omega, which is known as a frequency response function. After that, calculate the magnitude and phase angle for a given omega. You will be getting set of values. You will be calculating what is the magnitude and what is the phase angle. Then after that, draw the polar plot. After that, draw the polar plot, and after drawing, sometimes drawing the polar plot itself will be completing the problem. Some of the times they will expect you to locate the magnitude. So in order to find out the magnitude, what you have to do is, you have to check whether the plot is crossing real axis or not. If the plot is crossing real axis, you have to locate the intersection point where it is crossing. So just for that, I will write intersection point. If it is on real part, imaginary part will be equal to 0. If it is on imaginary part, real part will be equal to 0. So last problem I will solve. What is the magnitude as well as phase angle as well as polar plot, and we will be locating the intersection point where it is crossing. So if it is crossing real axis, locate the point at real axis. Point on real axis, there will be no imaginary point, so imaginary part will be 0. Similarly, point on imaginary axis, the real part will be equal to 0. If you equate imaginary part and real part equal to 0, you will be finding out what is the value of omega. So after finding the value of omega, find out the magnitude. So that will be the magnitude of the plot. Let us solve second problem. Draw the polar plot for open loop transfer function g of s is equal to 6 divided by s plus 1 into s plus 2. This is a function what they have given. What is the solution? First, you need to consider the open loop transfer function. Here, is this open loop transfer function? G of s is direct transfer gain, no? How it is open loop transfer function? Very important thing in this situation, G of s is open loop transfer function for unity feedback system. G of s, h of s, it is the open loop transfer function. If h of s is equal to 1, this means it is unity feedback system. So then open loop transfer function will be equal to only g of s. What is the conclusion? Conclusion is they have given open loop transfer function here. Start directly. So g of s will be equal to 6 divided by s plus 1 into s plus 2. My doubt was whether it is an open loop transfer function or not. With this justification, I got it is open loop transfer function. Open loop transfer function for unity feedback system. That's why there is no h of s term here. Then replace or put s is equal to j omega. After that, what we have to do is g of j omega is equal to 6 divided by j omega plus 1 into j omega plus 2. So this is frequency response function in terms of omega. After that, what we need to do is calculate the magnitude. What is the magnitude? Magnitude for the numerator, real part is 6, imaginary part is 0. 6 square plus 0 square with a root. 6 square and root will get cancelled. It is 6. And j omega plus 1, again j omega plus 1. So 1 is real part, omega is imaginary part. So 1 square plus omega square with root. This is a magnitude. So omega square plus 1, and again, what is the magnitude for this? Omega square plus 2 to the 4. Then find out what is the phase angle. Phase angle will be, there is no imaginary term in the numerator, hence leave that part. 0 by anything is 0, minus denominator j omega plus 1. Again, tan inverse of, it is imaginary part by real part. Imaginary part by real part. What is the imaginary part here? Imaginary part is omega tan inverse of omega by 1. It is omega minus, why minus? Because we are transforming denominator to the numerator. So 1 by tan inverse x can be written as minus tan inverse x. Minus tan inverse omega for imaginary part, 2 is the real part. So this is the equation for magnitude and phase angle. Find out the values omega, magnitude, phase angle. Usually you have to locate minimum 8 values. So use your calculator, fetch the equation, directly you will get. I will directly find out what is magnitude when omega is equal to 0. Omega is equal to 0, what is the magnitude? Magnitude will be equal to 6 divided by 1, root 1 is 1, 4, 6 by 4, it is around 1.5. What is the phase angle? 0, 0. Omega will be equal to 0, tan inverse of 0 is 0, again tan inverse of 0 is 0. This is 0 degree. Similarly, I will substitute value infinity for last maximum value. If I give infinity for this, the magnitude will be equal to 0, and what is the phase angle? Minus 90, minus 90. It is minus 180 degree. So it is moving from minus 180 to 0. That is a plot. Meanwhile, you have to write the values for different values of omega. 0.1, 1, 2, 10. So minimum there should be 8 values. By knowing the first value, minimum value and maximum value, I can draw a polar plot. I will plot a polar plot. Polar plot. So this is sigma. This is j omega. Sigma minus j omega. Sorry, minus sigma minus j omega. What is the minimum value? Minimum value is the magnitude 1.5. Omega will be equal to 0. So where is that? It is at 0 degree. Where is 0? So 0 minus 90 minus 180. So 0 is somewhere here. The magnitude will be starting here. What is the magnitude? Magnitude will be equal to 1.5. Then after that, so direction also you have to take care, because what is the direction here? Minus 180 minus 0. So minus 180 degree minus 0. How much? It will be minus 180. Minus 180 indicates it is a clockwise plot. It is a clockwise plot. This is very important here. Let us start the same thing. Clockwise. If it is goes like this, it is a counterclockwise plot. If it is goes like this, clockwise plot, only one. So here omega is equal to 0. What is the magnitude? Magnitude will be 1.5. Then again it will be minus 180 degree. Minus 180 degree is here, and the magnitude will be going to 0. So I will write that. So this is a plot I will get. So this is omega is equal to infinity, magnitude is equal to 0. This is a direction, and look what is the direction of the plot. The direction of the plot is in clockwise direction. Here you got negative. Negative indicates 180 degree clockwise. So intermediate points you can find out. Intermediate points, it will be like this. And here also you can locate what is the magnitude here. You can locate what is the magnitude. So it is crossing at imaginary axis. In imaginary axis, the real part is 0. If you equate the same expression, if you equate real part equal to 0, you will get omega, then after that magnitude. Just draw the polar plot is the question. Just I have written only the polar plot. Last problem, I will teach you how to find out magnitude and magnitude at the intersection point. Let us take the next problem, problem number 3. What is problem number 3? Again, draw the polar plot for a transfer function, open loop transfer function. G of s will be equal to 1 divided by s to the power of 4 into 1 plus s. So here s to the power of 4 is there. As usual, the first step is they have given directly the open loop transfer function itself. Hence put s is equal to j omega. G of j omega will be equal to, very important step, you got s to the power of 4 here. In the magnitude there will be no problem directly if you take s to the power of 4, but in the phase angle you will go wrong here. So be careful. So what I will do is I will split j omega into j omega into j omega into j omega. I have written s 4 times. S into S into S into S. Why? I will tell you. Into 1 plus j omega. As usual, calculate the magnitude. What is the magnitude? Magnitude for numerator is 1. Denominator, omega square with root, omega square with get cancels, you will get omega, again omega, omega, omega. So totally you will get omega to the power of 4 into square root of real part square, 1 square, imaginary part square, omega square. So 1 plus omega square. What is the phase angle? Here there is an important thing, phase angle. What is the phase angle for this? Just I will write here j omega plus 0. So this is imaginary part and this is real part. So tan inverse of imaginary part. What is the imaginary part? Omega by 0. What is omega by 0? Tan inverse of infinity. What is tan inverse of infinity? 90 degree. So I will shift this to a numerator. It will be minus 90. Again there is j omega. Minus 90, minus 90, minus 90. So 4 times. Minus 90, minus 90, minus 90, minus 90, minus tan inverse omega. So this is the equation for phase angle and it will be 9 4s are 36, minus 360 degree minus tan inverse omega. This is phase angle. So this, because of this I have done j omega. So if you have s square, you can write j omega into j omega. If it is s cube, j omega, j omega, j omega. S to the power of 4, same thing. But what is the phase angle? If you have s to the power of n, s to the power of n, so n into 90 degree. So this is a phase angle what you can draw. S to the power of n, it can be plus or minus n. N into 90 degree. Here you got minus 4 into 90 degree. It is minus 360 degree. Very important thing. This thing is very essential here. Otherwise you go wrong. Then as usual, find omega, magnitude and phase angle. First for minimum, I will take 0. What is the magnitude? Anything by 0 is infinity and phase angle is minus 360 degree. Then extreme case, infinity. If I substitute magnitude omega value infinity, anything by infinity is 0. Then tan inverse infinity is 90. 360 minus 90 is minus 450. So what is the angle coverage here? Minus 450 minus of minus 360. It will be minus 90. It will cover only one angle. So I will draw a plot. This is sigma minus sigma, j omega minus j omega, usually g of j omega, h of j omega plane. Here also the same thing, G of j omega h of j omega plane. You will be writing in frequency response function. This itself is frequency response function. You will be drawing the plot in this plane. Let us start the problem. The minimum condition, what is the minimum condition here? Minimum condition is minus 360. Minus indicates you need to move in clockwise direction. 0, minus 90, minus 180, minus 270, minus 360. This is a first point. Where you have to start the first point? Here minus 360 will be coming from infinity. Infinity I cannot show here. There is somewhere there is an infinity. I cannot show. So just I will draw a parallel to this. This indicates it is an infinity. Parallel to sigma line. So here omega is equal to 0. Magnitude will be equal to infinity. Then at what direction I have to go? I don't know still. What I will do is minus 450 minus of minus 360. How much it will be? 90 degree. You got minus. Minus indicates it is in clockwise direction. So 90 degree clockwise. How to move? You have to move in clockwise. There are two options. This is minus 360 degree and this is minus 450 degree. So either you can go here, it will be counterclockwise. If you go like this, it will be clockwise. So what is the magnitude? Magnitude will be 0. 0 means here. So this is a polar plot. So omega is equal to infinity, magnitude will be equal to 0. And what is the direction? Direction is 450 degree. So this is a polar plot. It is not intersecting anywhere. It is not in real axis or it is not in imaginary axis. Here intersection you need not be located, but locate in between values. This is very important. S square j omega into j omega. This split up is important here. If you miss the split up, then you go wrong in phase angle calculations. So don't miss that. Again in the problem number 4, they have given the open loop transfer function directly. As usual the step, first one is put S is equal to j omega. Some of the steps I will skip here. So g of j omega will be equal to k. So since the value of k is unknown, you can assume any value. For easy purpose, I will be assuming the value of k is equal to 1. 1 divided by s into s plus 1 into s plus 4. So I will write the magnitude and phase angle directly. What is the magnitude? Magnitude will be 1 divided by s is replaced with j omega. So this step, sorry, you have to write j omega. J omega, it is omega only into square root of omega square plus 1, omega square plus 4 4s are 16. This is a magnitude. And what is the phase angle? Phase angle will be, denominator I will shift, tan inverse of omega by 0 is infinity, 90 degree, minus tan inverse of imaginary part by real part, omega by 1. So tan inverse omega minus tan inverse imaginary by real. So whenever you have to calculate magnitude, so real part plus I into imaginary. This is a complex number. When you want to solve magnitude, square root of real part square plus imaginary part square. Whenever you want to solve the phase angle is tan inverse of imaginary part by real part. So these things you have to remember. Always we will deal with complex poles and complex zeros, in other words complex numbers. So this is a magnitude and phase angle. Calculate the magnitude and phase angles for different values of omega. Minimum 8 values you have to write here. So when you give omega is equal to 0, what is the magnitude? Since there is a omega in the denominator, if you give 0 it will be infinity. What is the phase angle? Phase angle will be minus 90, 0, 0, so it is minus 90. So calculate omega for 0.1, 0.2, 0.5, 1, 2, 10, etc. Minimum, you have to locate 8 to 10 values. Then you will be knowing how the plot will go. Then I will take maximum. What is the infinity? At infinity, the magnitude will be 0. And what is the phase angle? Minus 90, minus 90, minus 90. So it is minus 270. Very important problem, because similar type, minus 90 to minus 70, you will get a plot, you will get a segment in Nyquist plot. So this is very important. Let us solve this. This is sigma, this is j omega, this is g of j omega h of j omega plane. If you write S plane, that is also possible here. This is origin minus sigma minus j omega. Let us locate the angles. Angles is minus 90. Where is minus 90? 0. You have to move here. Clockwise direction you have to move. Clockwise direction 0, minus 90, minus 180. So minus 270 here. So minus 90 is here, minus 270 is here. The plot can start like this, or the plot can start like this. What is the angle coverage? Angle coverage is minus 270 minus of minus 90. So it will be 180 degree, minus 180 degree. It indicates 180 degree clockwise. So I will start here. It should be at infinity. So parallel to this. Then this is omega is equal to 0. Magnitude will be infinity. Here we are plotting for magnitude, not for omega. This is a magnitude plot here. Then go up to 0. This is 0. So omega is equal to infinity. Magnitude will be 0. Since magnitude is 0, we came here. So this is the direction of the plot. Look at the direction. It is clockwise. It will be covering 180 degree, 2 quadrants. Two things confusion will be there. How to start a plot? Should I start like this? I can start like this also, but the clock become counterclockwise direction. The direction will be reverse. So here 180 degree clockwise. This is the direction. Upper limit minus lower limit. This is very easy to remember. Then next problem. Again same thing. Directly they have given open loop transfer function. Put S is equal to j omega. So g of j omega will be equal to 10 divided by S square is there. Again j omega into j omega plus 1 into 0.5 j omega plus 1. So what is the magnitude? Magnitude will be equal to 10 divided by omega square, square root of omega square plus 1, square root of 0.5 omega square plus 1. Then phase angle. What is the phase angle? Minus 90 minus 90. Minus 180 degree minus tan inverse of omega minus tan inverse of 0.5 omega. After this, locate omega, magnitude and phase angle. Omega is equal to 0. What is the magnitude? Since omega is in denominator alone, directly you can write infinity. What is the phase angle? Minus 180 degree. And omega is equal to infinity. What is the magnitude? Magnitude is 0. What is the phase angle? Phase angle is minus 180, minus 90, minus 90. So it will be minus 360 degree. Because tan inverse infinity 90, tan inverse infinity 90. Minus 180, minus 90, minus 90. So minus 360. Let us draw a polar plot. This is g of j omega, h of j omega plane, j omega, sigma minus j omega. Same thing. See the magnitude of the plot. Magnitude of the plot is 180 degree. First locate minus 180 degree. This is 0, minus 90, minus 180. Then locate minus 360. Move again. Minus 270 degree, minus 360 degree. So the plot can start from here to here or here to here. For that you need to know direction. So minus 360 minus of minus 180. It will be 180 degree with minus. So 180 degree minus indicates it is a clockwise direction. So minus 180, it will be starting like this because it is parallel to infinity. then it will go to 0. So here magnitude omega is equal to 0, magnitude will be infinity. Here omega is equal to 0, magnitude will be, omega is equal to infinity, magnitude will be equal to 0, and this is the direction of polar plot. This direction is important. If you left this direction, 0, because we can assume in any direction. So direction is very important. Don't miss the direction of the plot. Here also the direction is very important. Then next problem is also same thing. Directly they have given, put S is equal to j omega. Here there is no S term in the denominator. It will make some difference, I will tell you. G of j omega is equal to 20 into j omega plus 5, and there is one term in the numerator, j omega plus 1, j omega plus 2 into j omega plus 8. So what is this is a frequency response function. Magnitude will be 20 into square root of omega square plus 25 divided by omega square plus 1 square root of omega square plus 4 square root of omega square plus 64. 8 8 is 64. What is the phase angle? Phase angle will be 20. Earlier directly we were taking negative because there were no terms in the numerator. So here there is a term in the numerator. So tan inverse of imaginary is omega, real part is 5, minus tan inverse of omega minus tan inverse of omega by 2 minus tan inverse of omega by 8. So this is the phase angle. Then after that, find out what is omega, what is magnitude and phase angle for different values of omega. If omega is equal to 0, what is the magnitude? Magnitude 20 into 0, 20 into 5 you will get. So here 20 into square root of 25, 500 divided by 1, 2, 8. So 100 by 8, some value you will get, fraction. So 20 into 5, that is 100 divided by square root of 1 is 1, square root of 4 is 2, square root of 64 is 8, 8 2s are 16, 100 by 16. So calculate what is the value of magnitude here. And phase angle is 0 degree, 0 0 0 0. Again for infinity, what is the magnitude? Magnitude will be, you give infinity here or infinity here, it will be infinite. But at this stage, it is very difficult to decide whether it is an infinite or not. In this case, you have to plot intermediate values. So find out what is the magnitude at point 1, find out what is the magnitude at point 2, find out what is the magnitude at point 3, 1, 10. Here intermediate values is essential because we don't know where is the plot going. So in this case, this is very important, intermediate values. So it demands intermediate values because magnitude is slightly unknown. You cannot predict here. You cannot predict the magnitude whether it is infinity or not. Here if you substitute, it will be infinity. Here if you substitute, it will be 0. We don't know what exactly is that. Okay, next let us take an angle. By looking into the angle, one can decide what is the magnitude. So here we don't know. Then what is the phase angle? Phase angle is 90 minus 90, get cancels. So it will be minus 180 degree. So what is the angle coverage? Minus 180 degree minus 0, it will be 180 degree clockwise. So write the plot here. This is sigma j omega minus sigma minus j omega, g of j omega, h of j omega plane. So what is the magnitude? 100 by 16, it is some fraction, and phase angle will be 0. I will be only concentrating on angles. 0, minus 90, minus 180, minus 270. So 0 to minus 180 it will go. So 0, somewhere here it will start. So this is 100 by 16 magnitude. It is a finite. It is not starting at infinite. Then minus 180. It should be clockwise plot. Since it is a clockwise plot, it will be like this. Already there is a finite magnitude. It will be coming from infinity. It cannot be infinite, because if it goes to infinite, the angle will be different. So that's why compulsorily it should be 0, and this value is 0. How you have written? This you have written by looking into phase angles. Sometimes the problem will be like this. So this is polar plot. So 180 degree clockwise. So this is the sixth problem. Some problems will demand intermediate values. Always I insist you to determine intermediate values, please. If you determine intermediate values, this value will be less than this value will be less than this, so that you can interpolate, and finally it might be 0. So always calculate intermediate values. And this I have written directly because you have to analyze this within a short span of time. Also, this problem will be asked for 8 marks. This problem will be asked for 8 marks, and in this problem it is crossing imaginary axis. In this problem it is crossing imaginary axis. In this problem it is crossing real axis. What we need to do here? We need to locate this intersection point. We need to locate here this intersection point. Here we need to locate this intersection point, and you need to find out what is the magnitude. So next problem I will take, I will calculate the magnitude. For all the problems you have to do this. Why I recommended to stop here means, if it is asked for 8 marks, this plot is sufficient. Draw the polar plot means just you need to draw the polar plot. And find the magnitude if they ask in the second part, then you have to find out the magnitude of the polar plot. Let us look into the last problem of the polar plot. Here, if you solve 100 problems, you will get 101 type. So rather than remembering the problems, you understand the procedure correctly. It is very important. If they mention in the question, find the magnitude of the plot, then you find the intersection point and locate the magnitude. Otherwise, just you end up with only drawing a polar plot, because second part of the question is there. It is a Nyquist plot. It is a big procedure. It will be a time consuming. So almost you simplify the steps. In the previous case itself, the same problem, only here the difference is you have to locate the intersection point. So I will start the problem. So the first step is put S is equal to j omega, and the given function is open loop transfer function itself. That's why I am directly taking and directly solving S is equal to j omega. So g of j omega into h of j omega will be equal to 12 divided by S square is there. Show the split up. Why split up? Because phase angle calculation. J omega plus 1 into j omega plus 2. What is the magnitude? Magnitude 12 divided by this omega square, square root of real part square plus imaginary part square, omega square plus 1 into omega square plus 4. And what is the phase angle? Phase angle is split up. Omega by 0 infinity, omega by 0 infinity. Since it is a denominator, take that to a numerator. Minus 180 minus tan inverse of omega minus tan inverse of omega by 2. Then locate the magnitude and phase angle for different values of omega. If I give omega is equal to 0, since there is a omega term in the denominator, anything by 0 is infinity. Directly write infinity. What is the phase angle? Phase angle is minus 180 degree. Then maximum value infinity, magnitude will be 0. What is the phase angle? Minus 180, minus 90, minus 90. So it will be minus 360 degree. Then locate the polar plot. Polar plot. This is sigma j omega minus sigma minus j omega. So where the plot starts? The plot starts at minus 180, 0, minus 90, minus 180, minus 270 and minus 360 degree. So how to take? What is the direction? Like this or like this? Again calculate the angle. Minus 360 minus of minus 180. So minus 360 minus of minus 180, it is 180 degree with minus, this indicates 180 degree clockwise. You have to move clockwise. So clockwise means 180 here it will be starting, the magnitude will be at infinity, and start the plot like this. It will go to 0. So this is a direction of polar plot. Same thing, last problems also you have solved clockwise plot, 180 degree angle coverage. Important thing here is you have to locate this intersection point. What is this point and what is the frequency here? So for that the procedure I will tell you. So take the open loop transfer function, g of s h of s will be equal to 12 divided by s square into s plus 1 into s plus 2. What I need to do is get the real part and imaginary part for this complex number. How to get? Rationalize it. This is basic PUC procedures. S minus 1, s minus 2, s minus 1, s minus 2. Then it will be 12 into s minus 1 into s minus 2 divided by s square minus 1, s square minus 4. So this is a complex transfer function. Replace s is equal to j omega, then 12 j omega minus 1, j omega minus 2 divided by j omega whole square, j omega square minus 1, j omega square minus 4. So 12, before that you multiply this j omega, it will be j omega whole square minus 2 j omega minus minus j omega plus 2 divided by j omega whole square minus 1, j omega whole square minus 4. Right now I am not worried about denominator because denominator part is converted to a real one, and this you can divide. I will take just a numerator. So 12 into j square is minus 1 minus omega square minus 3j omega plus 2 divided by the same denominator. Why I am writing denominator means this function you need not carry. What is the real part here? Real part is 12 into minus omega square plus 2 divided by denominator. It is the real part. What is the imaginary part? Minus 3j into omega divided by the same denominator. Again here 12 is also reflected. This is real part and this is imaginary part. Since you have point on intersection point on imaginary axis, so here the real part equal to 0. What is the real part? That one. So minus omega square plus 2 equal to 0. Denominator I won't worry. Why means this will go 0, no? That's why I am not worried. What is omega? Omega is equal to root 2 radian per second. And what is the magnitude? Magnitude, again you replace the value of root 2 in this equation, magnitude equation. 12 by root 2 square means 12 by 2. 12 divided by 2 into root 2 square. Root 2 square is 2, 2 plus 1, 3, square root 3 into again root 2, 2 plus 4, 6.